So picture this for a second. A celebrated astrophysicist is intensely studying the skies, right? They're combing through thousands of images from the state-of-the-art Event Horizon Telescope, hunting for the ultimate cosmic quarry. And finally, they spot the telltale signs. But as they really scrutinize the data, something is just completely wrong. It's a mind-bending mystery that literally defies reality as we know it. Welcome to today's Explainer, where we're going to dive into a phenomenon that has absolutely baffled the brightest minds in physics. Okay, let's jump right into this cosmic detective story. Looking at these new telescope images, the scientist sees something that should be entirely impossible. Right there, right in front of their very eyes, the black hole appears to be, well, burping. Yeah, burping. Now, you and I both know the golden rule of black holes, right? Nothing, not even light, can escape their gravitational grip. That's exactly why they're so incredibly hard to find. But here is photographic evidence of matter actually coming out of one. No way, right?
So what on Earth, or actually what in space, is going on here? Well, could it be that this isn't a black hole at all? It turns out we might just be looking at our prime suspect here, the black hole's neglected twin known as the white hole. So today we're going to investigate exactly what a white hole is, how it actually works, and if it even exists at all.
Section 1. Anatomy of a black hole, the baseline. So we all kind of know the extremes we're dealing with here. Ever since Einstein's 1915 theory of relativity, we've understood the singularity. It's an area so impossibly dense that space literally wraps around it and pinches off from the rest of the universe. To put that into perspective, a black hole the size of a single atom could weigh as much as a massive mountain. And you know what? That's just the tiny ones. When a dying star collapses, it creates a stellar black hole up to 20 times the mass of our sun. But then we have these supermassive black holes. 4 million. That's the sheer number of suns crammed into Sagittarius A star, which is the supermassive black hole sitting right at the center of our very own Milky Way. All of that insane mass is condensed into a tiny ball only as big as a few million Earths. Now, surrounding all that incredible mass is the event horizon, which is the strict threshold of no return. Think of it as a cosmic one-way street. Once gas, dust, or even light crosses this threshold, it inevitably falls straight toward the singularity. At that point, the whole concept of cause and effect is just completely shattered. For well over a century, these cosmic monsters only existed on chalkboards. In 1915, Einstein's equations calculated spacetime curves. Then, in the 1970s, Stephen Hawking theorized that they could actually leak energy. But it really wasn't until 2019 that the Event Horizon Telescope captured the very first image of a black hole's shadow. So while the math is over 100 years old, the actual visual proof is incredibly recent. Section 2. Enter the white hole, the reveal. So, from a distance, a white hole is an absolute master of disguise. It shares almost entirely identical traits with black holes. They can be massive or tiny. They might spin or just stay perfectly still. They can carry an electrical charge and even gather gas and debris at their edges. Honestly, they look exactly like black holes, right up until they suddenly burp. And boom, this is exactly where the disguise falls apart completely. A black hole's event horizon is the point of no return. But a white hole's, it's the exact opposite. It's the point of no admission. Absolutely nothing from the outside can ever cross in, but matter from inside the white hole can actually cross the event horizon and emerge right into our universe. Section 3. The time reversal theory. The interrogation. Now, according to physicists, a white hole is quite literally a black hole operating in time reversal. Just let that sink in for a second. Because of this time reversal, the interior of a white hole is completely and utterly cut off from the universe's past. Nothing that happens outside in the surrounding universe can ever have an impact on what is going on inside a white hole. Think about it like this. In a standard black hole, your destiny is sealed the moment you cross the horizon, right? Therefore, the black hole singularity exists in your future. But for a white hole, everything is expelled outwards. It's all coming from the singularity. Therefore, a white hole singularity exists entirely in the past. James Bardeen, who is a pioneer in black hole physics, absolutely nails how unsettling this whole concept is. He notes, somehow it's more disturbing to have a singularity in the past than can affect everything in the outside world. It completely flips our foundational understanding of reality right on its head. A singularity in the past that uncontrollably affects the outside world without ever being influenced by it Yeah, it's deeply disturbing to the foundational laws of physics.
Section 4. How do they form? Interrogating the theories.
We know black holes form from collapsing stars. So naturally, you might ask, does a white hole form from a reverse supernova? Well, here we run into the unscrambled egg problem. See, a white hole exploding into a fully functioning star completely violates the laws of increasing entropy. It's like, well, you simply cannot unscramble an egg once it's cooked. Furthermore, there is an immediate logistical problem here. Hal Haggard, a theoretical physicist at Bard College, points out that a long-lived white hole, I think, is very unlikely. And if you think about it, that makes perfect sense. If a white hole did manage to form and actually started burping out matter, that matter would immediately collide with all the gas, dust, and debris already gathered in orbit around its event horizon. The intense collisions and the resulting mass would likely cause the whole shebang to collapse right back into a black hole almost instantly. So, if they can't form backwards, where do they actually come from? Let's walk through Stephen Hawking's brilliant theory. General relativity says nothing escapes a black hole, but quantum mechanics says information can never be deleted. So what happens when a black hole dies? Well, step 1. The black hole leaks energy over billions of years, shrinking down to about 1 microgram, which is roughly the mass of a single human hair. Step 2. At this infinitesimally tiny size, it stops obeying normal gravity and the standard laws of physics. And finally, step 3. Hiding a cavernous interior full of literally everything it ever swallowed. This tiny, stable object finally spits that trapped information back out, becoming a burping white hole.
If this holds true, long after all the stars burn out, our universe might actually end up as a vast sea of tiny, burping white holes. But hey, relax. You don't need to cancel your weekend plans just yet. This crazy scenario requires a universe countless trillions of times older than ours currently is. Section 5. The ultimate white hole. The twist. Okay, get ready for this, because some black hole physicists believe we might actually be living inside the ultimate white hole right now. Crazy, right? But when you look at the mechanics of the Big Bang, an explosion of immense matter and energy erupting from a single impossibly dense point to create our universe, it behaves exactly, and I mean suspiciously, like the way theorists suspect a white hole acts. To ground this wild theory in reality, let's look at what physicist Hal Haggard observed. He says, the geometry is very similar in the two cases, even to the point of being mathematically identical at times. The geometry of a white hole releasing matter and the geometry of the Big Bang creating our universe are remarkably similar. This isn't just science fiction, folks. The math actively supports the comparison. Now, of course, a theory this massive attracts plenty of criticism. But as scientists point out, we really must follow this rabbit hole to the very end. Just because we haven't actively laid eyes on a white hole through a telescope yet, definitely doesn't mean it isn't out there. History has taught us time and time again that the theoretical math often predicts the physical reality decades in advance. The consequences of these theories are simply too fascinating to ignore. We are definitely still a long way off from watching a white hole burp matter in real time, but until we solve this epic cosmic mystery, I want to leave you with this final, stunning thought to take away from today's explainer. When we look up at the vast and unknowable universe, are we looking out into space, or are we simply looking at the inside of a white hole?